Hello everyone. A very good evening. We will be starting with chapter 5, that is basic concepts of permutations and combinations. In the previous session, we had completed chapter 4 and chapter 6 as well as chapter 3. So now we have 5, 7 and 8 that is left to be completed, right? So we'll start with basic concepts of permutations and combination. That is your chapter 5. Okay. Before we get into what is permutation and what is combination, first we need to understand two things. The first one being fundamental principles of counting, and then the meaning of the term factorial. What is this factorial? Which is very, very important from the point of view of solving any questions in this particular topic. Okay. First of all, fundamental principles of counting. So when do you add and when do you multiply? When should you add? When should you multiply? Let us take a very basic example, okay, to understand this. Now, let's say every day you travel from your college back to home. Yes. One instance, okay. Let's consider this as a task or a job. So what is your job right now? To travel from your college back to your home. That is your task or your job, right? So now to complete this task, can I say that, let's say you have three options. You can go by auto, you can go by bus, or you can walk. These are the three alternate or options that you have, okay? You have various, I know, but I have considered only three of them. Now, then you have to perform this task or a job once, correct? That is today. Let's say you have to go back to your home. Today you're in the college right now. You have to go back to your home. Now, out of these three options that you have, that is bus, walk, or auto, can I say you'll choose any one of them, right? So these three options are nothing but your three different alternatives. So if I have to put it in words, I'll say you'll either go by auto or by bus or by walk. So here, when you consider alternates of completing a task, what is it? When you consider alternates of completing a task or a job, then the addition rule, that is the OR rule, comes into picture. So auto becomes your one particular way, bus becomes another way, and walk is yet another way. So total number of ways here are three. So what does this mean? It means that there are three alternative ways of performing the job or the task. Okay. The next one is the multiplication rule. Now, multiplication rule is also called as the AND rule. Okay. Now, let's say you're traveling to any destination, your dream destination. I have to consider the example as Japan over here. Okay. Now, let us consider that to go to Japan, okay, to go to Japan, you have to go via Mumbai. Now, you are in Mangalore. I am in Mangalore right now, okay? Wherever you are. So, let's say to go to Japan, you have to go via Mumbai. Now, from Mumbai to Japan is from Mangalore to Japan is the task or the job. But when you have to reach Japan, you have to go via Mumbai, right? So now from Mangalore to Mumbai, Mumbai to Japan, that is how you need to go. So from Mangalore to Mumbai, let's say you have three options: bus, train, or flight. This is very similar to what we have done in the previous case. So once when you perform this task, which task? Going from Mangalore to Mumbai, you will consider any one of these three. So these three are nothing but your three different alternatives: bus or train or flight. So going from Mangalore to Mumbai, you have three ways. And then from Mumbai to Japan, can I say you have two ways? Okay. Now I'm using the word and. I'm telling Mangalore to Mumbai and Mumbai to Japan. So the word and comes into picture. And when the word and comes into picture, we have multiplication rule. That is the and rule. So three ways into two ways gives us a total of 6 ways. Okay. So this is your addition rule and multiplication rule. So when you have an alternate to perform a job, it is OR rule. That is the addition rule. When you have to perform two or more tasks one after the other, then you have the multiplication rule. That is the AND rule. So OR means plus and AND means into. Now, the next important concept is understanding what is this factorial. Now, these are the two ways in which a factorial can be represented. So this is called n factorial or factorial of n. Okay, these are the two ways in which the factorial can be represented. Now here in example 1, they have asked us to find the value of 6 factorial. How do you get this? This is nothing but starting from 6, the product of all the integers from 6 till 1. The product of all the integers from 6 to 1. That means 6 into 5 into 4 into 3 into 2 into 1. That will give us the answer as 720. So what is 6 factorial? It is the product of all the integers from 6 to 1. And similarly, what is 8 factorial? 8 factorial is the product of all the integers from 8 till 1. So 8 into 7 into 6 into 5 into 4 into 3 into 1. So the answer here being 40,320. All right. This is your factorial. So factorial of n means, which is written as n factorial or factorial of n, product of all the integers from n to 1. It is the product of all the integers from n to 1. All right. I hope this is clear. Now, this can also be written as n factorial is equal to n into n minus 1 into n minus 2 and so on till 3 into 2 into 1. Ultimately, last value should be 1. Okay. Now, the value of 0 factorial. Factorial of 0 is equal to 1. Okay. A few examples how to solve factorial. If you have 8 by 4 factorial, 8 factorial by 4 factorial, you cannot cancel 4 ones are 4 twos are 8. Okay. It's not values. It cannot be cancelled as values. So you have to find the value of 8 factorial and 4 factorial and then cancel them. Okay. Similarly here, second example, 6 factorial into 2 factorial. You cannot multiply 6 into 2, 12. No. You have to find the value of 6 factorial. You have to find the value of 2 factorial and then find the final answer. Same thing with addition and subtraction. So whenever factorials are given, you cannot multiply them or divide them as it is. You have to either find the value or you can cancel same values in the factorial. 4 factorial can be cancelled. All right. This is your basics before we start with permutations. Okay. Now, in permutations, let us understand with the help of an example. Now, the basic difference between what a permutation is and what a combination is, I will help you with the help of, I will explain it to you with the help of an example. The same example that I'm taking right now for permutation will be taken for combination as well. The reason for that is you can clearly make out the difference between the two. Okay. Once you get the difference between what is permutation and what is combination, then it becomes easier for you to solve the questions. All right. So now let's say there are 3 students, A, B, and C. Now in case A, I'm saying you have to arrange all the 3. Okay. So what are the possible ways of arranging all the 3? A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. So can I say there are 6 ways of arranging? Okay. Now move to case B. What is given in case B? Arrange 2 out of the 3. What is arrange 2 out of the 3 means? You have to arrange any 2 of them out of the 3. How do you arrange any 2 of them? You pick any 2. So A, B, C are 3 people. Let's say A, B. Now, if you consider A, B, you can write A, B as well as B, A. If you consider A, C, you can consider A, C as well as C, A. If you consider B and C as the persons, you can consider B, C as well as C, B. So here also you get 6 ways. Okay. It's a mere coincidence that we're getting 6 in both the answers. Okay. It's not the case everywhere. Okay. So what you need to understand from here is what are we doing in permutation? In permutation, we are arranging. What are we arranging? We are either arranging people or we are arranging objects or we are arranging things. So what are we doing under permutation? We are actually arranging. All right. Now, here in this 2 examples, can I say the total number of people that we have is 3? Correct? The total number of people that we have is 3 and this is represented as n. So what does n mean? N means the total number of people. Okay. And in case A, how many have we considered for each arrangement? We have considered all the 3 people for each arrangement, which means R also is equal to 3. Okay. Now in case B, how many have we considered for each arrangement? We have only considered 2, which means R is equal to 2. What is this R? R is nothing but what is the consideration or number of people or things that we have considered for the arrangement. They are also called as factors. Okay. Now, so what have we done here? What have we done is we have arranged. So we have arranged R objects out of n different objects. Why n different objects? Because A, B, C are 3 different people. Okay. So we have arranged R objects out of n different objects. So the number of permutations of R objects, number of permutations of R objects out of n different objects is denoted as NPR or P of n comma R, where the formula for NPR is n factorial divided by n minus R factorial. All right. So now in this example, what is our NPR? That is 3P3, correct? N is 3 and R is also 3. So here NPR will be 3P3, which is 3 factorial by 3 minus 3 factorial. That is 3 factorial by 0 factorial. What is the value of 0 factorial? 0 factorial is 1. What is 3 factorial? 6. So the answer is 6. And in the second case, NPR will be 3P2, which is 3 factorial by 3 minus 2 factorial, 3 factorial by 1 factorial, which is also equal to 6. So what you need to understand from here is, yes, we found out how many ways are there. But in the exam, what we need to find is what are the possible ways and not the possible arrangements. No, this arrangement is not required to be found out. Okay. So here also 6 and here you get 6 using the formula. All right. So what is n for us? Total number of objects. And what is R? The number of selections that we have made. All right. So one more important aspect here to understand is when you consider n and R, the values of n and R should always be positive integers. What is this positive integers? Anything which is 1, 2, 3, 4, 5, 6, not minus 1, not 1 by 2. Because when I say there are 10 people, okay, when I say there are 10 people, can I say out of the 10 people, I will select 5.5 people? Possible, which means that both n and r should be positive integers. Can you have negative numbers? Definitely not. Can you have fractions 1 by 2, 1 by 3? Not possible. Okay. One more important note here is with respect to n and r, the value of n should always be greater than or equal to r. Okay. Value of n should always be greater than or equal to r. Okay. Now, few notes. NPN can also be written as n factorial. That means 3p3 is 3 factorial. Okay. NP0 is 1. NP1 is n. And NPN minus 1 is n factorial. If you remember this, you can solve this few questions quickly and easily. All right. Let's take a few examples to go ahead. Find the number of different words that can be formed with the help of the letters of the word famous. What is the word here? The word is famous. Now, in the word famous, how many alphabets are there? There are 6 alphabets, right? Now, the 6 alphabets are different from each other, correct? So, can I say n is equal to 6? Now, in this particular question, they have not given how many alphabets are required to be arranged, which means all the 6 are required to be arranged. So, NPR will be 6P6, that is 6 factorial, which is equal to 720. Now, there is another way to solve this. What is this other method of solving? Now, famous is a 6-letter word. That means 6 spaces are there. Okay. Now, if you take the first place, can I say there are 6 options possible? F, A, M, O, U or S. Now, one of the option is placed in the first place. Next, you have 5 options here. Next, you have 4 options, then 3 options, then 2 options, and then 1 option. Now, you have to multiply everything because It is every alphabet that forms the 6-letter word, not only one of them or not any one of them. Okay, so it's 6 into 5 into 4 into 3 into 2 into 1, which is 720. All right. Now, next question. Find the number of different 3-letter words that can be formed with the help of the letters of the word famous. Again, n is equal to 6, but here they have given 3-letter word, which means r is equal to 3. So NPR will be 6P3, 6 factorial by 6 minus 3 factorial, that is 3 factorial. So 720 by 6. 720 divided by 6, that is equal to 120. I hope this is clear. And the other way of solving this is a 3-letter word. So it is 6 possible ways, 5 possible ways, and 4 possible ways. 6 into 5 into 4, 120. Okay. Next question they have given is, find the number of different words that can be formed by rearranging the letters of the word famous. Okay, the word rearranging. Now, how many possible arrangements are there in the letters of the word famous? 720, right? Now, in this 720, is famous included? Yes, famous is included because they are all the possible arrangements. Okay, in this 720, famous is included. Therefore, when they say rearranging, what you do is you have to subtract 1 from the answer, making it 719. All right. But in the previous question, that is question number 2, if they would have said rearranging, would you subtract 1? No. Answer would have still been 120 because in the 3-letter word, famous is not included. Okay. In very good, Pratiksha. Yes. In the 3-letter word, famous is not included. I hope this is clear. All right. Next, we go to numbers. So here they have asked, how many 3-digit numbers can be formed with the help of the digits 1, 2, 3, 4, and 5? Okay. So what is n here? N is 5. What is r? R is equal to 3. So NPR will be 5P3. All right. You can get the answer. Next, how many 3-digit numbers can be formed with the help of the digits 1, 2, 3, 4, 5, and 0? So what is n here? 6. What is r? 3. Can I directly write 6P3? No, not possible. Why is that? Because when you write 6P3, there is a possibility that 0 occupies the hundreds place. Right? So when 0 occupies a hundreds place, it is not a 3-digit number. So it can be any other number other than 0, which means there are 5 options. But 0 can occupy the tens place or the units place. Correct? So when you come to the tens place, you have 5 options again, which includes 0. And when you come to the units place, you have 4 options. So answer is 5 into 5 into 4. 5 into 5 into 4, 25 into 4 makes it 100. I hope these are clear. Okay. All right. Next one, moving to permutations of n things when some of the things are alike. What do you mean by alike? When they are similar, when they are same. Okay. Now, observe this. Formula, we'll come back to it, but get the solution first. Varanasi. Let's say the word Varanasi. So what is there in the word Varanasi? We have A that is there 3 times. Correct? We have A that is there 3 times. How many letters are there in the word Varanasi? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. So here, when you get the permutation, it is 8 factorial by 3 factorial because repetition should be divided. Yes, correct. Yes. Okay. And when you come to the word calculator, how many alphabets do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So N is equal to 10, wherein C is repeated 2 times, correct? A is repeated 2 times, right? And L is also repeated 2 times. So you will get 10 factorial divided by 2 factorial into 2 factorial into 2 factorial. So anything that is repeated should be considered separately divided by. Okay. All right. Next one is permutations of n things such that two particular things never occur together. Okay, we have a simple formula given here, n minus 2 into n minus 1 factorial. All right, but I'll give you two methods to solve this, okay? Because one of these methods is very important from the point of view of examination. There are quite a few questions which can be asked. Now, let's say we have A, B, C, D, E to be arranged in a row such a way that A and C do not sit together. Okay, the method one, which is finding out all the possible arrangements. All possible arrangement. What are all possible arrangement? 5 factorial base, correct? 5p, 5 or 5 factorial base. But can I say in this 120, A and C being together is also included? In this 120, A and C being together is also included, which means you have to minus. What do you have to minus? You have to minus all the arrangements where A and C sit together. So to do that, what you have to consider is A and C as one term. Okay. Remaining B, D, and E will be considered as 3 different terms. Total making it 4 things. Now 4 things can be arranged in 4 factorial ways. Agreed? Yes. But see here, A and C can be arranged within themselves in 2 factorial ways. How is that, you ask? See, we have only considered A and C together. We have not considered their arrangement. A and C can be arranged as AC or CA. That is why it is 2 factorial ways. And to get the total arrangements of 5 things, we have to do both. First, you have to arrange the 4 things and as well as arrange A and C. So answer here would be 48. 24 and 24. 4 factorials, 24, 24 into 2. 48. The total number of arrangements where A and C do not sit together is 120 minus 48, that is 72. Okay. Now, the reason why I did this as a different method or a method is this is important where 2 people or 3 people sit together. Such a question is asked usually from the point of view of examination. Now, method 2 is using the formula. What is the formula? N minus 2 into n minus 1 factorial. What is n here? 5. A, B, C, D, E. 5. N minus 2 is 3 into n minus 1 factorial, which is 4 factorial. Answer is 3 into 24. That is 72. And if you can observe here, you got the same answer. Yes, different method. Of course, if the direct question is asked, you'll use the formula method. But this is important from this particular point of view where 2 people or 3 people sit together. All right. Okay. Next one is sum of our digit numbers. Okay. So when the numbers are given without 0, so that when the digits are there without 0. So here you have a formula. You have to find the sum, not number of numbers. You have to find the sum of numbers. Here you have a formula. N minus 1p r minus 1 into summation of the digits into 111 r times. Okay. Clearly write what is the value of n here. That is 1, 2, 3, 4 and 6. That means 5. And r here is 3. So n minus 1 will be 4 p2 into summation of the digits. What are the digits here? 1 plus 2 plus 3 plus 4 plus 6. All right. Into 111 r times. What is r here? 3. So how many times will 1 be there? 3 times, which is read as 111. Okay. So 4p2 is 4 into 3. That is 12 into next. You have 1 plus 2 plus 3 plus 4 plus 6. That is 16, right? Into 111. So you get 12 into 16 into 111, making it 21,312. Okay. Now, similarly, we have one more where the digits given are without 0. Okay. This is a little lengthy formula, but important. Okay. So here, what you have is you have 0 in the digits. Simple way is you take n. N is 1, 2, 3, 4, 5, 6, 7. And r is 4. First, you do the summation of the digits. What is the summation of the digits? 3 plus 2 plus 4 plus 6 plus 8 plus 0 plus 1, which is 24. Into n minus 1p r minus 1. which is 6p3, okay, into 111r times 4 times minus n minus 2, that is 5p2 into p r minus 2 into 111 r minus 1 times. What is r here? 4. So 4 minus 1 will be 3. So how many times 1? 3 times 1. What is 6p3? 120. What is 120 into 1111? You get 24 into 1,33,320 minus 5p2 is 20 into 111. That is 2,220. So the final answer here would be 31,46,400. Okay, this is your summation or sum of the digits. All right. Okay, next, permutations with restrictions. Where's, see, permutations of r things, okay, r different objects out of n distinct objects, where one particular object is not taken in any arrangement, not considered at all. So the formula is n minus 1p r. Okay, and here when one particular person is always taken in any arrangement, always considered, the formula is r into n minus 1p r minus 1. And if you add the two, that is n minus 1 pr plus r into n minus 1 pr minus 1, you will get npr. Okay. Next, you have circular permutation, which is arrangements around a circle. Now, I've considered 4 people, A, B, C, D. And if you can observe, there are 6 possible ways to arrange these 4 people. 6 different ways to arrange these 4 people. Unlike your seating arrangement, there is no south, north and all, everything here. Okay. It's the same. 6 possible ways, which is given as n minus 1 factorial. That means 4 minus 1 factorial, that is equal to 3 factorial, which is 6 ways. So linear permutation is 4 factorial and circular permutation is 4 minus 1 factorial. Okay. So the formula given here is n minus 1 factorial. So if I say 5 girls are to be arranged in a row, answer is 5 factorial. But if it is a circle, answer is 4 factorial. Next, if you have to form a necklace or a garland, where there is no distinction between the clockwise and the anti-clockwise direction, then the formula is half of n minus 1 factorial, or it can also be written as n minus 1 factorial divided by 2. The same formula used in one more concept, where if you're seated around a round table such that no person has the same 2 neighbors, then every alternate possible arrangement will get eliminated. Here also the formula is half of n minus 1 factorial. Okay. With this, we are done with permutation. Let's quickly understand combinations. So now in combinations, what do we have? I've taken the same example, 3 students. Okay. Now I have to select these 3 students. I have to select 3 students. No arrange, select. When you say select 3 students, can I say irrespective of this? This is nothing but arrangement, right? Irrespective of this, your selection is nothing but the same 3 people. Your selection is nothing but the same 3 people, that is A, B, C. How you select is not important, whether it's A, B, C or A, C, B is not important. Your selection is nothing but the same 3 people. So can I say here it can only be done in one way? Only in one way. Now when it comes to any 2 out of the 3, be it AB or BA, it is the same. Correct? Be it AC or CA is the same. Be it BC or CB is the same, right? So you have, this is one alternative, or this is another alternative, or this is the third alternative, making it 3 possible ways. What is that? AB, BC or AC. Arrangement is not important. All right. So here n value is 3, r value is 3, and here n is 2 and r is 2. What is n and r remains the same. Now in permutation, the formula was n factorial by n minus r factorial. Since in combination, the arrangement is irrelevant. The formula is n factorial by n minus r factorial into r factorial. Because why are we dividing by r factorial? Is because the arrangement is irrelevant. All right. Okay. N and r is the same. Meaning of n and r remains the same. The relation between n and r also remains the same. Okay. First note. NCR and NCN minus R are equal to each other. That means if you have 10C3, this 10C3 is also equal to 10C7. Okay. Next. NCN is equal to 1 and NC1 is equal to N. Next. If you have NCR and NCR plus 1, its value is N plus 1 CR. That means 10C8 plus 10C7 is equal to 11C8. Okay. Next important one. NCR is equal to NCS. Then we can say that N is equal to R plus S. See here. 10C3 and 10C7 are equal to each other. Okay. Which we understood in the first property, first note. Now we can say that here 10, that is N, is equal to 3 plus 7. This is your important property here. Okay. Next, you have combination of R1 things from N1 things and R2 things from N2 things. Where you have two separate categories. Okay. Now here I've given you I've given you 6 alphabets and 5 digits. And what have I told you? I've told you that you have to select 3 alphabets and 2 numbers. So out of 6 alphabets, you can select 3 alphabets in 63 ways. And out of 5 numbers, you can select any 2 in 5C. 2 ways. This is where your N1CR1 into N2CR2 rule comes into picture. Okay. Combination of different things taken one or all at a time. Combination of different things taken one or all at a time. Okay. Let us understand this with the help of an example. Let us say I give you a box of 5 chocolates. Okay. I give you a box of 5 chocolates with a condition that you have to consider one, at least one or more, correct? At least one. But when I say at least one, can you consider 2? Can you consider 3? Can you consider 4, 5, 6? No, 6 is not possible because the box itself has 5 chocolates. So, depending on who you are, you may select 1 chocolate or 2 chocolates or 3 chocolates or 4 chocolates or 5 chocolates. Okay. So this is your rule where combination of one or all at a time. So 1 means 5C1 plus 5C2 plus 5C3, 5C4 plus 5C5. Okay. The another way to solve this is by using the formula, which is 2 to the power n minus 1. Now, why have I taught you the first method is, if suppose they say maximum 3 chocolates, 1 or up to 3 chocolates, then can I say these 3 things would be your answer? Yes, 5C1, 5C2, 5C3, wherein the formula cannot be used. The formula can only be used when it is 1 or all. Okay. Method 2 is nothing but using the formula. The formula is 2 to the power n minus 1. 2 to the power 5 minus 1. I hope this is clear. Okay. Combination of allied things. So where P, Q and R are repetitions. So when there are repetitions in combinations, what you need to do is the number of times one term has occurred. That means any number has occurred plus 1. Second type, third type, and ultimately multiply this and reduce it by 1. Okay. Number of diagonals in a polygon. Now, what is a polygon? Excuse me. What is a polygon? A polygon is any closed shape. Is a triangle a polygon? Yes. But does triangle have diagonal? No. So, what is a polygon? A polygon is any shape with sides. Okay. Any closed shape. Now here, types of polygons that have a diagonal is, first one, quadrilateral. What are types of quadrilateral? Square, a rhombus, rectangle, parallelogram, all these are quadrilaterals. Next one is pentagon. 5 sides, hexagon 6 sides, heptagon 7, octagon 8, nonagon 10, and nonagon 9, and decagon 10. So how do we find out? We simply have to multiply, we simply have to take the value of n. Let's say, how many sides are there in a decagon? 10 sides are there. How many diagonals are there? It is 10 into 10 minus 3, 7 divided by 2. 70 by 2, that is 35. So there are 35 sides in a decagon, 35 diagonals in a decagon. All right. Okay. Now, note for permutation and combination. If you do NPR by NCR, you'll get the value of R. Okay. If you do NPR by NCR, you will get the value of R factorial. I hope this is clear. Okay. Quickly do the questions of permutations. Then we can start with set relations and functions. Find the ways in which the letters of the word software be arranged such that all the vowels are together. Okay. Now, in the word software, what are the vowels? O is a vowel. O is the vowel. Yes or no? What is the next vowel that we have here? A and E. Right? O is the vowel, A is the vowel, and E is the vowel. What are the remaining alphabets? S, F, T, W, R. Correct? Now, if this is to be together, then like I told you, this should be considered as 1. Plus, how many are there over here? 5. Total 6. Okay? And 6 things can be arranged in 6 factorial ways. O, A, and E within themselves can be arranged in 3 factorial ways. So it is 6 factorial into 3 factorial, that is 720 into 6, 4300. And hope this is clear. Okay. There are 10 flights operating between city A and city B. The number of ways in which a person can travel from city A to city B and return by a different flight. Very simple. To go from city A to city B, you have 10 possible flights. So 10 ways. And to come back, one of the flights gets eliminated because it said a different flight. There are 9 ways. So 10 into 9, 90 ways. That's all. Okay? Yes. Next one. The number of parallelograms that can be formed by a set of 6 parallel lines intersecting another set of 4 parallel lines. Okay. To form a parallelogram, you need 2 vertical parallel lines and 2 horizontal parallel lines. Only then you will get a parallelogram. So if 6 parallel lines are intersecting a set of 4 parallel lines, can I say it looks something like this? Okay. Now from the vertical lines you need 2. From the horizontal lines also you will need 2. Right? From vertical lines you will need 2. From horizontal lines you will need 2. How many vertical lines are there? 6 are there. So from this 6 you will need 2. Now see here, it is not arrangement, it is selecting. Only selecting. You're selecting the lines, that's all. You're not arranging them. And you will need 2 of the horizontal lines. That is 4C2. Okay. So it is 6C2 into 4C2. 6C2 is 15 and 4C2 is 6. So 15 into 6, that is equal to 90. All right. Next one. In how many ways can a selection of 6 out of 4 teachers 6 out of 4 teachers and 8 students be done so as to include at least 2 teachers? At least 2 means minimum 2. Minimum 2, 3 or 4. Okay. So first 2 teachers and how many students? 4 students. Correct? Next, 3 teachers and 3 students. Next, you have 4 teachers and 2 students. Okay. How many teachers are there? 4. So 4C2. Here it is 4C3. And lastly, it is 4C4. And is into how many students are there? 8 students are there. So 8C4, 8C3. Here it is 8C. Now this is case A or case B or case C. Get the values. Okay. Add them. You should get the answer. All right. Okay. These are the values. These are the options. You can solve it. I hope it is clear. You just have to use the NCR formula and get to the answer. Okay. A student has 3 books on computer, 3 books on economics, and 5 books on commerce. If these 3 books are to be arranged subject-wise, then these can be placed on a shelf in the following number of ways. Subject-wise, you have to arrange the books. So first 3 books will be computer. Then 3 books will be economics, something like that, correct? But it need not always be computer. So computer is considered as 1. Economics is considered as 1. And commerce is considered as 1. So 1 plus 1 plus 1, total 3, which can be arranged in 3 factorial ways. But these books within themselves can be arranged in n factorial ways. That means 3 computer books can be arranged in 3 factorial ways. 3 economics books can be arranged in 3 factorial ways. And 5 commerce books can be arranged in 5 factorial ways. So the final answer is 3 factorial into 3 factorial into 3 factorial into 5 factorial, because this is arranging computer books. This is arranging economics books, and this is arranging the commerce books. Okay, I hope this is clear. 6 into 6 into 6 into 120. That is 25,920 is your answer. Next. A question paper consists of 10 questions. 6 questions in maths, 4 questions in stats. Find out the number of ways to solve the paper if at least 1 question is to be attended from each section. Okay, minimum 1. Minimum 1 will mean maximum 6 from maths and maximum 4 from stats. So it is, if I have to say minimum 1, can I use the word 1 or all? So 1 or all will mean we have to use the value 2 to the power n minus 1. This is 2 to the power 6 minus 1 and 2 to the power 4 minus 1. Which is 64 minus 1, that is 63 here into 15. 63 into 15 is 945. Remember this is the concept of 1 or all under combination. Arrangement is not required here. The letters of the word violent are to be arranged so that the vowels occupy even places only. The number of permutations are. Arrangement is important. Permutation is given. Okay. What is the word? The word is violent. In the word violent, what are the vowels? V, I, O and E. What are the consonants? L, N, E. Correct? What have they said? Vowels are to be arranged in even places. How many letters are there in the word violent? There are 7 letters. Correct? What are the even places here? Second, fourth. 1 minute. Just a minute. Okay. All right. So, sorry, here actually there's a small mistake. So it should be consonants in even places. Okay. Consonants. All right. So consonants in even places. All right. So what are the consonants here? There are L, N, and T. Three consonants, three even places. Okay. Three consonants in three even places can be arranged in 3 factorial ways, and remaining vowels in the remaining places in 4 factorial ways. Okay. So consonants are to be arranged in even places. So how many consonants are there here? There are three consonants. What are those three consonants? L, N, and T. Okay, I'm so sorry. I've considered the vowels wrongly. A, E, I, O, U are the vowels. V is not a vowel. Yes, the question is correct. Here, V should be here. Okay, so what have they told here? They have considered that the vowels. Yes, correct. Sorry, my bad. Yes. So vowels are to be in even places. Correct. Vowels are to be in even places. So what are the vowels here? The vowels are I, O, and E. So how many are there? How many options are? How many values are there here? Second place, fourth place, and sixth place. Correct. O, I, O, E. Okay. I, O. Yes, correct. There are 4 consonants and 3 vowels. Okay. Yes. I, O, and E. Now here, I, O, and E are 3 vowels. 3 vowels in 3 even places. In how many ways? 3 vowels in 3 even places in 3 factorial ways. All right. Now you have 4 consonants. V, L, N, and T. 4 consonants in the remaining places. In how many ways? 4 factorial ways. So what is the answer? It is 3 factorial into 4 factorial. That is 6 into 24, 140. Okay. Yes. All right. Okay. That's all with permutations and combinations. We can start with set relations and functions. Now in set relations and functions, we will quickly glance through the concepts once. Yes. All right. Okay. What is a set? A set is a collection of distinct and defined objects. So here, if you observe, I've given a few examples, and out of these examples, 2, 3, and 4 are not a set. Why? Because in example 2, A is repeated twice. In example 3, the brackets are not flower brackets. In example 4, the denotion of a set is given with small letter. What does this mean? This means that a set cannot have repetitions. A set should be denoted with flower brackets only. And the denotion of a set should be done with only a capital letter. All right. Okay. Set can be given in 2 forms. Listed form, braces form, or roster form, or a described form, which is also called a set builder, rule method, or algebraic form. What is this listed form? Listed form is where the elements are given, mentioned. Described form is where you have to find the elements. Like for here, example, they have given set A is equal to X. Now the symbol is such that X is greater than or equal to 1, less than or equal to 5, which means the values of set A will be 1, 2, 3, 4, and 5. Okay. Next, they have given set B is equal to X, where X is an vowel, which means B will be A, E, I, O, and U. Okay. Is this clear? All right. Now, this is already spoken about. The order is not important. Set cannot have repetitions. Okay. So, if it is there a repetition, it is not a set. Next one is cardinal number. Cardinal number means the number of elements, which is denoted as n of A. So if a set A is given, the cardinal number of set A is n of A. Now here you have a set A which has 1, 2, 3, 4, 5, 6, 6 elements. So n of A is equal to 6. Next, moving on to types of sets. First one is finite set. Finite set means where there are finite number of elements. Infinite set, infinite number. Null set means with no elements. So null set is either represented with only the brackets or this Greek alphabet called phi or phi. Now these two are not null sets, okay? Remember, singleton set, which has one element, okay? Next, universal set, which has all the possible elements. Like for example, students of CA foundation batch. So whatever number of students are there in your batch, all the students are included there. Or for example, alphabet. So if you say alphabet A to Z, it is an universal set. Okay. Next one that we need to understand is what is a subset. A subset is a set which is derived from the universal set. Okay. Or we can call this universal set as the superset. Okay. Now, if I say there are 20 students in the class, for example, and I want to form a subset. What is that subset? A subset where all the students clear the exams. Example, okay? All the students clear the exams. Now here, I'll get the subset as 1 to 20. 20 students are there. So this I can write this as C is the subset of A, which can be read as C is the subset of A or A is the superset of C. Coming to the next example, which is proper subset. Now, what is this proper subset? Now, let's say we have a set alphabet. From that, I have to derive another set, which is vowel. Vowels are A, E, I, O, U. Now, in this set, are there all elements from set B? No. There are few elements which are not there in D, but there in D. So, that is why we call D as the proper subset of D. See the symbols very carefully. When you say subset, you write an is equal to below. And when you say proper subset, you do not. Okay. Now, what are the possible subsets here? If a set is given as A, 1, 2, 3, possible subsets are 1, set 2, set 3, 1, 2, 1, 3, 2, 3, 1, 2, 3, and null set. Okay. These are all the possible subsets that you have. Okay. But now what you need to understand over here is when in a set, all the elements are there of the superset, that is not a proper subset. So other than 1, 2, 3 here, other than this set which I've marked in red, that is 1, 2, 3, all the remaining sets are proper subsets. Okay. All the remaining sets are possible subsets. Null set is always a subset. Okay. Number of subsets is 2 to the power n. So here n is 3. 2 to the power 3 is 8. And if you observe here, there are 8 possible subsets. And number of proper subsets are 2 to the power n minus 1, which is 7. Okay. And here, this set 1, 2, 3 is excluded. Okay. Next, power set. It is the set of all the subsets. So all the subsets written together as a set forms the power set. Equal sets. Equal set means when 2 or more sets have the same elements. Order is not important. See here, 1, 4, 6, 8. Here it is 1, 4, 6, and 8 in different order. But they are still equal because the elements are the same. Okay. Equivalent set. What is equivalent set? When 2 sets have the same cardinal number. When 2 sets have the same cardinal number, they are called equivalent. See here, n of A is 4, n of B is 4, n of A and n of B are equal to each other. They are called equivalent. Now, can I say all equal sets are equivalent? But we cannot say vice versa. We cannot say all equivalent sets are equal. Next, operations on sets, union and intersection, which you have done in statistics. Union means adding all the elements together and adding all the elements but not repeating the elements, and intersection means taking only common elements. So A union A is A union E. Here, E means superset. Okay. And A union null set is A. A intersection A is A intersection E is also A intersection null set is null set. Complement of a set, anything other than set A. So here you have superset E, which has 15 elements, 1 to 15. Set A has 1, 2, 3, 4, 5, 6. So complement of set A will have anything other than set A. That is 6, 7, 8, 9, 10 to 15. Okay. So you have A union A dash will be equal to E. A intersection A dash is null set. And complement of a complement is nothing but A. Difference between sets. Set A and set B is given. If you have to find A minus B, consider set A. Whatever are repeated in set B, remove it. So see here, in B, 2 is there, 4 is there, and 6 is there, eliminated. So set A minus B will be 1, 3, 5. Okay, B minus A, consider set B. Whatever is there in A, remove it. That is 2, 4, 6. So set B, B minus A will be 8, 10, 12, and 14. Okay. Next, you have union and intersection. Okay. N of A, N of B, N of A union B and A intersection B. So to find N of A union B, you have a very simple formula. N of A plus N of B minus N of A intersection B. Now, if I say N of only A, N of only A, it is N of A minus N of A intersection B. Why is that? What is this N of only A? This N of only A is this area. A part of A which does not intersect with B. Okay. Now, next, N of A union B whole dash. A union B whole dash. This A union B whole dash is the outer part of this circle. What is N of A union B whole dash? It is anything other than N of A union B. So N of S, that is the total, minus N of A union B. You'll get N of A union B whole dash. Next, you have something called as disjoint sets. Okay, where the set are not intersecting each other. So here, N of A union B will be N of A plus N of B. N of only A is nothing but A. And N of A intersection B is 0. That is nothing. A intersection B is a null set. So cardinal number is 0. Okay. Next, we have Cartesian product of set. So you have to find the product set here. You have two sets A and B. If you have to find the product set A cross B, A by B, first element is A, second element is B. It is ordered pair. So 1, 8, 1, 9, 2, 8, 2, 9, 3, 8, 3, 9. This is your Cartesian product of set. So this is nothing but ordered pairs. When I say ordered pairs, the order is important. So the first element belongs to set 1, that is A, and second element belongs to set B. In B cross A, the first element will belong to set B, second element will belong to set A. So 8, 1, 8, 2, 8, 3, 9, 1, 9, 2, and 9, 3. All right, this is your Cartesian product. So number of elements in a Cartesian product is N of A cross B, which is nothing but N of A into N of B. So in the example, N of A was 3, N of B was 2. Total 6 elements. If you observe here, 1, 2, 3, 4, 5, and 6 elements are there. Next, moving on to relations. Now, what is a relation? A relation is where the ordered pairs are related to each other. Okay, every subset of the product set is a relation. Every subset. Okay, now here you have 1, 2, 3, 4 and 1, 2. That's two sets. So ordered pairs A cross B are given as follows. I have defined the relation where I said A is greater than B. Okay, so if A is greater than B, we have 2, 1, 3, 1, 3, 2, 4, 1, and 4, 2. Correct? Yes. Now I've said A is equal to B. If A is equal to B, then you have 1, 1 and 2, 2. That is your relation. Very simple. You have two things to understand here, domain and range. Domain means all the first element of the ordered pair, and range is all the second elements of the ordered pair. Again, I'm saying it is a set, so there cannot be repetitions. Okay, so 2 can be written only once, 3 can be written only once, similarly 4. Same in the case of range. Here domain is 1 and 2, range is 1 and 2. So what is domain? It is the first element of ordered pair. It is a set. Range is a set of second element of the ordered pair. Okay. Next, you have types of relation. First one is identity relation. It is a relation with itself. So 1, 1, 2, 2, 3, 3. Next, you have is reflexive relation. Now, in reflexive relation, you can either have 1, 1, 2, 2, 3, 3. That should be there. Now, with this, you can have any other element. Okay. That is called your reflexive relation. It may be there or may not be there. Okay. A relation with itself with any other element is called an reflexive relation, which is denoted with R. Next, you have symmetric relation, transitive relation, and then equivalence. Okay, let's take an example. Symmetric. What is the symmetric relation? Now, in case of symmetric relation, if you have A comma B, then you should have a corresponding B comma A. So if you have 1 comma 2 and if you have a 2 comma 1 in the relation, then it is called a symmetric relation. If A comma B is not there, then B comma A need not be there. But to call a relation symmetric, if A comma B is there, then a corresponding B comma A should be there. Now what is transitive? If A comma B is there and B comma C is there, then you should have a corresponding A comma C. So for every A comma B, B comma C, there should be a corresponding A comma C. That is your transitive relation. Okay. Now what is equivalence? Equivalence is where a relation is reflexive, symmetric, and transitive. All the three together. Inverse relation, ulta. Every ordered pair, if you just reverse the order, it becomes your inverse relation. Okay, with this we are done with relations. Next, moving on to functions. Now, in case of a function, let's say we have here two sets, A and B. A has 4 elements and B has 8 elements, and 4 8s are 32. So total 32 elements will be there. But what I'm asking here is relation 1. I'm talking about relation now. We are yet to go to function. What I'm asking you is a relation now. Relation where A is greater than B. So if I ask you A is greater than B, you're going to give me these ordered pairs, where the domain is going to be 2, 3, 4 and the range is going to be 1, 2 and 3. Second, I'll ask you a relation where B is equal to 2A. 2 times A is B. Okay. So this is what you get: 1, 2, 2, 4, 3, 6 and 4, 8. Domain is 1, 2, 3, 4. Range is 2, 4, 6 and 8. Okay. I'll give you one more. Set A, set B. Different example. Okay. F of x function, which is given as x square, where set A is the input and set B is the output. So if you insert the value of x as 1, you should get the answer as x square. 1 square, that is 1. If you insert the value of x as 2, you'll get 2 square, that is 4. If you insert the value of x as 3, you'll get 3 square, that is 9. And if you insert the value of x as 4, you'll get 4 square, that is 16. Okay. Now, out of these 3 examples that we have taken, okay, out of these 3 examples that we have considered, one of them is not a function. One of them is not a function. Now, which one is this that is not a function? The first example is not a function. Why? Because in the first example, every input, that is, if you observe the first element, 2, 3, 3, 4, 4, 4, first element in the first relation, first element is there in more than one place. 2 is there once, 3 is there twice, and 4 is there thrice. Okay. When you come to example 2, if you observe, the first element is there only once. So what is a function? A function is a relation wherein every input has only one output. Every input has only one output. So what is a function? A function is a relation where every input has only one output. Okay. Can there be any outputs that is left alone? Yes. Can there be any input that is left alone? No. So every input must have an output. Only then you call it a function. Okay. All right. Now see here. The first one here that we have is a function because every input has an output. This diagram is called mapping. It's called arrow diagram. Here. Every input has an output. Next. Every input has an output. Yes, correct. A has one, B has one. One output. Every input has one output. If the output is same, that does not matter. But one input cannot have more than one output. Here, A, B, C, D, 1, 3, 4. Okay? Yes. Now moving to the next one. This is not a function. Why? Because input D does not have an output. Next. This is also not a function because A has two outputs. C also has. So every input should have only one output. Only then we call it a function. Function is also called as mapping. Types of functions. First one is identity function. Identity function where a input output are nothing but the same. A comma A, B comma B, C comma C. Next you have constant function where every input has the same output. Okay. Every input, which is also called as pre-image, has the same output, which is called as image. Next, you have 1-1 function, which is also called as 1-1 mapping, where every input has a different output. Every input has a different output. These are examples of 1-1 function or 1-1 mapping. Next, you have many-one function, where more than one input has the same output. More than one input has the same output. See here, A and B have the same output. Similarly, here also A and B have the same output. Okay. On to function, surjective function or surjection, where every output has an input. Till now we studied function means every input should have an output. Okay, so one onto function, surjective function means every output should have an input. Every output should have an input. Okay, see here. The first example, this is 1-1 and onto. 1-1 and onto. One input, one output, one input, one output. And every output has an input. And here it is many-one and onto. Why many-one? Because more than one inputs has the same output. Next, into function. Into is the opposite of onto. Onto means every output should have an input. Into means where one or more outputs do not have an input. Again, into function can also be 1-1 and into, many-one and into. Next, bijective function. Bijective function means a function which is 1-1 and onto together. Okay. Next, you have composite function, which is function of a function. Let us understand this with the help of an example. So here you have f of x and g of x. You have to find f of g of x, which means in the place of x in f of x, you will substitute the value of g of x. So you get the answer as 2x cube plus 8 plus 3, 2x cube plus 11. And g of f of x means in the place of x in g of x, you will substitute the value of f of x. This is your composite function. Lastly, you have inverse function. If f of x is given as 2x plus 3, then what you need to do here is you have to find the inverse. Inverse here is not directly ulta. You have a 4-step thing. You have a 3-step process. Follow that. First, you consider f of x as y. Okay. So y is equal to 2x plus 3. Second, you find the value of x. What you'll get, y minus 3 is equal to 2x. So y minus 3 divided by 2 is equal to x. Okay. Is this clear? Lastly, replace y with x and replace x as f inverse of x. This is your answer. So this is how you find the inverse function. Is this clear? Yes. With this, we are done with set relations and functions. We'll quickly take up the questions. I hope it is clear. Okay, first question. The set of cubes of natural numbers. Natural numbers. What are natural numbers? 1, 2, 3, 4, 5, 6, and so on. All these are natural numbers. Set of cubes of natural numbers. 1 cube, 2 cube, 3 cube, 4 cube. You can go on till infinite terms. So can I say it is an infinite set? So if you say 1, A, set A, 1 cube, 2 cube, 3 cube, so on. Natural numbers are infinite terms. So here also it will be an infinite set. Okay, next question. A is given as 1, 2, 3, 4, 5, 6, 7, 8, 9, and B is given as 1, 2, 3, 4, 1, 3, 4, 5, 7, 8. C is 2, 6, and 8. You have to find the value of A minus B union C. First, let's find A minus B. A minus B. 1 is there, 2 is not there, 3 is there, 4 is there, 5 is there, 6 is not there, 7 is there, 8 is there, 9 is not there. And what is C? C is 2, 6, and 8. You have to find A minus B union C, which is 2, 6, 8, and 9. Option C. If it was asked A minus B intersection C, then the answer would have been 2 and 6. I hope this is clear. We go to the next question. In a class of 35 students, 16 students play football. Okay. N of football is 16. Total is 35, correct? 24 students play cricket. So N of C, let us consider as 24. Assume that each one plays at least one game. Assume that each one plays at least one game, which means N of football union cricket is 35. N of football union cricket is 35. And the number of students who play both the games. Both the games means intersection. So what you have here is football union cricket is equal to N of football plus N of cricket minus N of football intersection cricket. Yes, 35 is equal to 16 plus 24 minus N of football intersection cricket. Shift this here. You will get 16 plus 24, 40 minus 35. So N of football intersection cricket is 5, which means there are 5 students who play both. Next question. The number of subsets that can be formed from the letters of the word Allahabad. What is the word here? Allahabad. What you have to find? Number of subsets. To find number of subsets, this word should be written on a set first. Okay. So let us say set Z is equal to A, L, H, B, D. Okay. Now you might wonder, why did I miss 1L, 1A, again A? Because a set cannot have repetitions. A set cannot have repetitions, right? So here in the word Allahabad, how many letters are there? In the word Allahabad, there are more than 5. But when you consider it in a set, you can only have 5 elements. Okay. So how many subsets are possible? It is 2 to the power n, which is 2 to the power 5. That is equal to 32. Okay. Next one. Set A is given as 1, 2, 3. Then the relation 1, 1, 2, 3, 2, 2, 3, 3, 1, 2 on A is, that is A product of, Cartesian product of A cross A. A cross A. Can I say here all the possible identity relations are given? And over and above the identity relation, there is something else, which means that it is a reflexive relation. Okay, it is not symmetric, it cannot be transitive, nor it can be equivalence. Okay, next one. You have to, f of x is given, you have to find the value of f inverse of x. You have to find the value of f inverse of x. So we'll consider this as y is equal to 2x cube plus 1. Y minus 1 is equal to 2x cube. So you get y minus 1 divided by 2 is equal to x cube. Cube you shift to the other side, it becomes 1 by 3. So you have y minus 1 divided by 2 whole to the power 1 by 3 is equal to x. Now replace y as x and x as f inverse of x. So we'll get the answer as x minus 1 whole divided by 2 whole to the power 1 by. Okay. Next. Set A is given, set B is given. You have to find which of the following relation is a function from A to B. From A to B means first element of the ordered pair is A and second element is B. Now, in the first set A, there are 4 elements. So there should be 4 ordered pairs because every input should have an output. There should be 4 ordered pairs because every input must have an output. So we can directly eliminate these two. Okay, now let's check. Does every input have a different output? We have to check. Correct? Every input has an output. We have to check. A has P, B has R, C has Q, and D has S. Every input has an output. Therefore, option C is your answer. Okay. With this, we are done with relations, functions, and set relations and functions. Let us quickly go to calculus. Okay. We'll keep it simple. We'll understand the formulas and try to solve the questions. A quick revision of calculus. Okay. Not detailed. I cannot explain. It's not possible for me and not required also right now to go into detailing here. So what is derivative? A derivative of function y. Derivative of function y is written as dy by dx. So what are you doing here? You're finding the derivative of the function with respect to x. Okay. Now, let's understand the standard formulas here. If you remember the standard formulas, half of your job becomes easy. Okay. So now what is the derivative of x? It is 1. What is the derivative of a constant? 0. Why? Because constant does not change. Yes. Next. So derivative of 10 is 0. What is the derivative of x to the power n? Now what is this x to the power n? Variable is x, n is the constant. So variable to the power constant. The derivative is n into x to the power n minus 1. So see here, if you have x to the power 4, derivative is 4 into x to the power 4 minus 1, that is 3. Next you have x to the power minus 4. Minus 4 into x to the power minus 4 minus 1, that is minus 5. Next, derivative of a power x. Now what is this a power x? It is constant to the power variable, where it is a to the power x into log a. So 4 to the power x will be 4 to the power x into log 4. What is the derivative of log x? 1 by x. Okay, but here the base is e. If the base is anything else, that is a constant, then what you need to do is you have to apply change of base. Log x by log a. Now log a you have to take it outside because it's a constant, correct? And you have to just find the derivative of log x. So log a into 1 by log a into 1 by log x is your answer. Next, derivative of e to the power x is e to the power x itself. Derivative of 1 by x is minus 1 by x square. Okay. And derivative of root x is 1 by 2 root x. All these are nothing but your x to the power n formulas. Okay. But to keep it easier, to make it simple, you remember this. Okay. Next, rules. Constant rule. What happens in constant rule is a function is multiplied with a constant, k into f of x. So in this case, you simply take k outside and find the derivative of the function. So here you have a function y as 5 into x cube. Here 5 is your constant and x cube is your function. So take 5 outside. Find the derivative of x cube. What is the derivative of x cube? 3x square. Why 3x square? Because x cube is in the form of x to the power n. So n into x to the power n minus 1. So total answer, final answer here would be 15x square. Next, you have the sum rule, okay, wherein you have two values, two functions which are added or subtracted. Now, in this case, what you simply have to do is you have to find the derivative of u separately, v separately. U is one function, v is another function here. Find the derivative of u separately, v separately. I have given an example here. So you have 3x square plus, 3x square plus 3 to the power x minus e to the power x. What is the derivative of 3x square? It is 3 into 2x, 6x. What is the derivative of 3 to the power x? 3 to the power x is in the form of a to the power x, which is 3 to the power x into log 3. And what is the derivative of e to the power x? E to the power x itself. So whenever it is addition or subtraction, you have to find the derivative separately, okay? And write it as. Next, you have the product rule, which is a function multiplied by another function, u into v. So here in case of product rule, it is u into derivative of v plus v into derivative of u. Let's take an example to understand this. Let's say we have a function x square into log x. How do you understand whether you have to apply product rule? See here, these are two different functions. That x square is x to the power n function and log x is log x itself. There are two different functions which are multiplied with each other, right? So firstly, x square as it is into derivative of log x. What is the derivative of log x? 1 by x, okay? Plus log x into derivative of x square. What is the derivative of x square? 2x. So here you get x square into 1 by x plus log x into 2x. Simplify this, you'll get the answer as x plus 2x log x. So this is your product. Next, you have the division rule, wherein it is function divided by another function, u by v. What you need to do here is denominator, that is v, into derivative of numerator minus numerator into derivative of denominator divided by denominator square. Let's understand this with the help of an example. Here, what is the denominator in the example? X to the power 4. So x to the power 4 into derivative of a to the power x, which is a to the power x into log a base e, minus, what is the numerator? A to the power x into derivative of the denominator. What is the derivative of denominator? It is 4x cubed divided by denominator square, which is x to the power 4 whole square. Okay, this is how you find the derivative using the division rule. Next, you have derivative of composite functions, chain rule. In chain rule, what happens is, now observe carefully over here, you have a function y is equal to log of 1 plus x square. Now, in the basic formulas, if you go through it, you do not have the derivative of log of 1 plus x square. You just have the derivative of log x. Correct? So, in the place of 1 plus x square, what is there? Sorry, in the place of x, what is there here? 1 plus x square. But when you find the derivative, you find normally, that is, what is the derivative of 1 plus x square? Log of 1 plus x square, 1 by 1 plus x square. Now, because in the place of x, something else has been replaced, you have to multiply this with the derivative of that something else. What has been replaced in the place of x? 1 plus x square. So you have to find the derivative of 1 plus x square, which is 1 by 1 plus x square into 0 plus 2x. 0 plus 2x is 2x. So you get the answer as 2x by 1 plus x square. Okay, this is how you apply chain rule. Next, one more question. Here, if you observe carefully, you do not have the derivative of x cube plus 2x whole to the power 4. You have the derivative of x to the power 4. What is the derivative of x to the power 4? It is 4 into x. X here is 3x cube, x cube plus 2x to the power n minus 1, 4 minus 1, 3, into d by dx of x cube plus 2x. Okay. So what you get here is 4 into x cube plus 2x whole to the power 3 into 3x square plus, so this is here. Next you have implicit function, where a function is given with respect to x as well as y. That means when a function cannot be written with respect to x alone. Till now, if you have observed, we had seen all functions where x was written as it is. So when a function cannot be written in terms of x alone, then you call it as an implicit function. Okay. Next one is a logarithmic function, wherein you have to apply log to solve the answer. Now here, if you go through the basic formulas, you have x to the power n, you also have a to the power x. But do you ever have x to the power x? Which means it is not possible to solve it as it is. That means you have to apply log on both the sides. So when you apply log on both the sides, you will get log y is equal to x log x. Log y is equal to x log x. Now, what is the derivative of log y? Derivative of log y is 1 by y into dy by dx. Why into dy by dx? Because instead of x, we are differentiating y is equal to, here you have to apply the product rule, which means first term into derivative of second term plus second term into derivative of first term. Right. So what do you get here? You will get 1 by y dy by dx is equal to x gets cancelled, 1 plus log x. So dy by dx can be written as y into 1 plus log x. Okay. This means dy by dx, in the place of y, we can write x to the power x into 1 plus log. This is your next parametric. So what is parametric function now? Where x and y are given. That is, two different functions are given with respect to another variable t. So let us say here we have another variable t. So instead of f of x and g of x, we have f of t and g of t. So to find the derivative of f of t, that is, it is dx by dt, and that of y is dy by dt. So to find dy by dx, you have to do dx by dt divided by dy by dt divided by dx by dt. Let's take an example. Okay, let's say we have two functions. X is equal to 3t and y is equal to 3t square plus 4. Now, what is the derivative of x dx by dt? Because we are differentiating with respect to t. So you get 3 into 1, that is 3. What is the derivative of y here? Dy by dt. So you get 2t plus 0, that is 2. So what is the final answer? 2t divided by 3. Okay, is this clear? Dy by dt will be 2t divided by 3. Okay. Next, you have higher order derivative. Higher order derivative is differentiating the term again. That is second derivative. D square y by dx square. Slope of the tangent to the curve or gradient of the curve. So if they ask you, they give you a function y, anything, y is equal to something, a function, and they ask you the slope, simply have to find dy by dx. That's it. Okay, simply have to find dy by dx. Sometimes what they'll do is they'll give you the value of x. If they give you the value of x, you have to substitute x in the place of x in dy by dx. So for example, let's say you have, okay, and they've said at x is equal to 4 or 0, let's say 0. So what is dy by dx here? It is 2 into 3, 6x square plus 3 plus 0. Okay. Now they have said dy by dx at x is equal to 0, which means value of x is 0. 6 into 0 square plus 0. Okay. So here the answer will be, this is how you will solve slope of a curve. Okay. Next question, the next concept, I'll explain it with the help of question itself. We'll quickly go through the questions of differentiation. Okay, first one. E to the power minus xy minus 4xy is equal to 0. Okay, so we have to find the derivative of this. We'll consider them separately. Okay, we can also start it like this. We can write this as e to the power minus xy is equal to 4xy. Can I say this is an implicit function? Because here we cannot write y in terms of x. Okay, this function is f of x comma y. Okay, now what is the derivative of e power something? E to the power x we know. What is the derivative of e to the power x? It is e to the power x itself. Correct. So here e to the power minus xy will remain e to the power minus xy itself into. In the place of x, we have substituted minus xy. Therefore, we have to find the derivative of minus xy is equal to 4 into d by dx of x comma x xy. Okay. So you have e power minus xy into. Here, can I say minus x is one term, y is another term. So product rule is applicable. So minus x into dy by dx plus y into minus 1 is equal to 4 into x into dy by dx plus y into, I hope this is clear until here. Yes? Okay. So what do you get? E to the power minus xy into minus x dy by dx minus y is equal to 4x dy by dx plus 4y. Now get all the terms, open the brackets first. You'll get e to the power minus xy, sorry, minus e to the power minus xy into x into dy by dx and minus e to the power minus xy into y is equal to 4x dy by dx plus 4y. Now your step is to get the terms with dy by dx on one side, shift this here and 4y here. You'll get 4y minus e to the power minus xy into y. Now see here, now you're not using derivative. Okay, now you're not using derivative. Now what are you doing? Now you're only simplifying it. Is equal to 4x dy by dx plus e to the power minus xy into x dy by dx. Now take whatever is common outside. Here I can take minus y outside. What remains? 4 plus e to the power minus xy. Here you can take x dy by dx outside. What remains? 4 plus e to the power minus xy. So this gets cancelled. X can be shifted here. Answer is minus y by x is equal to dy by dx. Okay. Yes. It is a little lengthy, I understand. But still, it is not impossible. It is possible if you practice. All right. Okay. Next question. X cube minus 2x square y square plus 5x plus y minus 5 is equal to 0 at x is equal to 1 and y is equal to 1. Okay. So what have they asked here is dy by dx at x and y equal to 1. We'll start. We'll start with finding the derivative. Now again, this is an implicit function. Okay, let's start. So you have x cube, which is 3x square minus, I'm finding the derivative. Okay, 2 is the constant into x square into y square is product rule. So x square into derivative of y square is 2y dy by dx plus y square into derivative of x square is 2x plus 5 into 1 plus dy by dx minus 5 derivative is 0 is equal to 0. Now you have 3x square minus, open the brackets, 4x square y dy by dx minus 4xy square plus 5 plus dy by dx is equal to 0. Okay. Now get the terms with dy by dx on one side. So you have 3x square here minus 4xy square plus 5. Take dy by dx common. 4x square y minus 1. This is what you get. Now you have 3x square minus 4xy square plus 5. Get the entire term here. You get 4x square y minus 1 is equal to dy by dx. Now substitute the value of x as 1 and y as. So you'll get 3 into 1 square minus 4 into 1 square plus 5 divided by 4 into 1 square into 1 minus. So numerator is 3 minus 4 plus 5, which is 4, and denominator is 3. So dy by dx is 4 by. Okay. If you have any doubts, kindly drop. Next one. X to the power y into y to the power x is equal to m, where m is a constant. Now here, x to the power y also is not there in basic form. Y to the power x is also not there. So how do you solve this? You solve this using log. All right. So how do you solve this using log? You apply log on both sides. When you apply log on both sides, you'll get log into x to the power y into y to the power x is equal to log m. You apply log a into log ab property here, which is log a plus log b. So you get y log x plus x log y is equal to log m. Okay. Next, what you need to do is you have to apply product rule here as well as here. Okay. What is it? Product rule, first term into derivative of second term plus second term into derivative of first. So y into 1 by x plus log x into dy by dx. Next, plus x into 1 by y into dy by dx plus log y into 1 is equal to derivative of 1 by log m is 1 by m into m derivative is 0. So answer here would be 0. Now simplify this. You'll get y by x plus log x into dy by dx. Correct? Plus x by y dy by dx plus log y is equal to 0. Now shift all the terms with the other than dy by dx on the other side. Here you can take dy by dx common. What remains? Log x plus x by y. And on the other side, it is minus log y minus y by x. Take a common denominator. Dy by dx into y log x plus x by y is equal to minus, take minus outside. Minus outside, you will get x log y plus y divided by x. Now shift this here and this here. What you'll get the answer is dy by dx is equal to minus y into x log y plus y divided by x into y log x plus. This is your final option B. Right. Yes. Cost function. So now what is this cost function? This cost function comes into picture when you have fixed cost and variable cost. Cost function means a total of fixed cost and variable cost. The fixed cost change does not change, okay? It remains the same, whereas the variable cost changes with respect to the change in the units. Now, what is average cost? Average cost is total cost divided by total output. What is marginal cost? Marginal cost is derivative of cost function, which is change in the value with respect to x. Now, slope of average cost is derivative of average cost, and slope of marginal cost is the derivative of the marginal cost. Now, in example like 4, what have they asked us is the cost function of the commodity is given as. The cost function is given as C of x is equal to 150x minus 5x square plus x cubed by 6. You have to find the value of x where marginal cost and average cost are equal to each other. Now, what is average cost? Average cost is cost function divided by x. So it is 150x by x minus 5x square by x plus x cubed by 6x, because every term should be divided by x. So you get 150 minus 5x plus x square by 6. This is your average cost. What is marginal cost? Marginal cost is d by dx of cost function. So marginal cost here would be 150 minus 10x plus 3x square by 6. So you have to find the value of x where average cost and marginal cost are equal to each other. So average cost is equal to marginal cost. You have 150 minus 5x plus x square by 6 is equal to 150 minus 10x plus 3x square by 6. 150, 150 you can cancel. Shift 10x to the other side and x square by 6 here. You will get 5x is equal to 3x square minus x square divided by, shift this here, get 30x is equal to 2x square. 30 by 2 is equal to x square by x, which means 30 by 2 is 15, x square by x is x. So value of x is equal to 15. So average cost and marginal cost are equal to each other when the output is 15 units. This is what it means. Now remember, this is one of the easiest questions that can be asked in the exam and usually being asked in quite a few of the attempts with respect to cost function, or the next question that I'm going to do with respect to minimum and maximum values. Okay. Next question. The cost function to produce x units of a commodity is given by C of x is equal to 2x cubed minus 15x square plus 36x plus 15. The cost will be minimum when x is equal to. When is the cost? Minimum is what you have to find. Now, let's keep it simple. They have asked us what is minimum? Cost will be minimum. Okay. So it's a 4-step process. If they would have asked average cost will be minimum, then you would have found out average cost and then done the 4 steps. If they would have asked marginal cost will be minimum, same thing. You would have found out marginal cost and then done the 4 steps. Okay. Now they have asked us cost directly, which means directly do the 4 steps. What is this 4 steps? First, find out dy by dx. What is find out dy by dx? Find dy by dx of cost function. Okay. So here, let's say cost function is y is equal to 2x cubed minus 15x square plus 36x plus 15. So dy by dx will be 6x square minus 30x plus 36. Okay. Next, take dy by dx as 0. Step 2. Dy by dx is 0 and find x. Okay. So you get 6x square minus 30x plus 36 is equal to 0. Now, when you simplify this, it's a quadratic equation. And when you solve this, you will get 2 values of x. That is, x is 3 and x is 2. Okay. Step 3. Find d square y by dx square, which is 12x, 6x square is 12x minus 30. Okay. Lastly, fourth step. Substitute value of x, that is 2 and 3, in d square y by dx square. Okay. So what is d square y by dx square? First, let's take x is 2. Then let's take x is 3. So you have 12 into 2 minus 30. 12 into 3 minus 30. 12 into 2 minus 30 is minus 6. And 12 into 3 minus 30 is plus 6. Okay. Now, they have asked us cost will be minimum. Cost will be minimum. Okay. Now, cost will be minimum when d square y by dx square is a positive value. What is it? D square y by dx square is a positive value. Therefore, we say that value of x is equal to 3. So when will the cost be maximum? Cost will be maximum when it is a negative value. Okay. So now here, these 4 steps are very important. Step 1 is find dy by dx. Step 2 is consider dy by dx as 0 and find the value of x. Step 3 is find d square y by dx square. And step 4 is find the value of d square y by dx square by substituting x that you have got. If it is positive value, then it is point of minimum. And if it is negative value, positive value means point of minima and negative value means point of maxima. I hope this is clear. Okay? Yes, all right. Integration will quickly understand the basic formulas. All right, we'll keep it simple. Let's understand the basic formulas. Whatever possible questions we will solve. Okay, so first, what is integration? Integration is the opposite of differentiation. So in differentiation, if you're moving forwards, integration will come backwards. Okay, so the first basic formula is integration of x to the power n dx. Okay, this is the symbol of integration here. It is x to the power n plus 1 divided by n plus 1 plus c. This constant is always to be added when you integrate with respect to x. But when you're finding the value, there is no constant that needs to be added. All right. So now integration of x to the power 4 is x to the power 4 plus 1 divided by 4 plus 1, which means x to the power 5 by 5 plus c. Now see here, I've differentiated this. What is the derivative of x to the power 5? It is 5 into x to the power 4. And derivative of divided by 5 is as it is, divided by 5 itself. So 5 and 5 gets cancelled. Derivative of a constant is 0, which gives us the answer as x power 4. Got it? So if you reverse what you have done in differentiation, you get the value of integration. Okay. Now, integration of dx. Dx means 1 dx and that is x. Okay. Next is integration of 1 by x dx. Log of mod of x plus c. A to the power x is given as a to the power x divided by log a base e plus c. And integration of e to the power x is e to the power x plus c. Next, you have integration of a into x plus b whole to the power n, which is a to the power x plus b whole to the power n plus 1 divided by a into n plus 1. Let's take an example here. So now here, 2x plus 3 is in the form of ax plus b, which is ax plus b whole to the power n plus 1 divided by 2 into y, 2 is a here, a into 4 plus 1 plus c. Okay, next is integration of 1 by x plus b dx, which is log of mod of a x plus b divided by a plus c. Next, you have integration of e to the power px plus q, which is e to the power px plus q divided by p plus c. And then you have integration of x square 1 by x square minus a square, which is 1 by 2a into log of x minus a divided by x plus a plus c. Okay, these are a few important formulas that you need to remember. Next, definite integration, wherein you have to find the value. No, plus c is not there. So only in case of indefinite integration is where you add c. There is a definite integration, that means you're finding the value. There is no plus c that needs to be added. Okay. Now what is the value integration of x to the power 4? It is x to the power 5 divided by 5. Okay. Now here they have given us values of x, which is 1 and 3. Highest value is 3 followed by lowest value 1. So first you substitute the highest value. So here I have substituted the value of x as 3 minus value of x as 1. Okay. Sorry. Value of x is 3. Next value of x is 1. Correct? Yes. So here you get 3 minus 1. Sorry, not 3. It is 243. 243 by 5 minus 1 by 5, which is 242 by. Okay. Next, what you have is integration by parts. Now here, if it is sum or difference, okay, sum or difference, u plus v, you integrate it separately. U integration separately, v integration separately. Now here it is integration by parts, which is one function multiplied by another function, u into v. Okay. Now here, unlike differentiation, there is an order of preference to select u. What is that order of preference? The order of preference is given as LAE. What is this LAE? L means log, A means algebraic, and X is exponential. So if a log value is given, that is always considered as u. If log is not given and a to the power 3 and e to the power x is given, then x to the power 3 and e to the power x is given, then x to the power 3 is considered as u. So this is the order of preference to consider L, A and E. Okay. All right. Yes, we'll do a question for this. Don't worry. Yes, let's quickly solve question number 6. 3 minus 2x minus 4 to the power x integration. So what is the integration of 3? 3 is a constant. So x dx there. Sorry, dx. Integration of 3 dx. 3 is constant. So only dx. That is 3x. Correct? Minus 2 is a constant. Integration of x, which is x square divided by 2. 2 gets cancelled. So minus x square. Correct? Next, minus integration of x to the power 4 dx, which is x to the power 5 divided by 5. So minus x to the power 5 divided by 5 plus k. K or c, dependent on what is given in the question. Okay? Yes. Next one. Find the integration of integrate 4x plus 5 whole to the power 6. Now, can I say this is in the form of ax plus b whole to the power n? So what is the integration of ax plus b whole to the power n dx? It is ax plus b whole to the power n plus 1 divided by a into n plus 1 plus k. Which means here the integration will be 4x plus 5 whole to the power 6 plus 1 divided by 4 into 6 plus 1 plus k. So you have 4x plus 5 whole to the power 7 divided by, what is 4 into 7? It is 28 plus k. Okay, option A is your answer. Next question. Integration of x into e to the power x. Now see here, two functions are multiplied. So integration by parts is applicable. Now when integration by parts is applicable, you have to follow the LAE method. Log is not there. Next is A, that is algebraic, which is x. So our u is going to be x and our v is going to be e to the power x. Okay, so how do we start first? X into integration of e to the power x dx minus integration of d by dx of u, that is x, into integration of e to the power x dx into dx. U into integration of v dx minus integration of derivative of u into integration of v dx. Sorry. Okay. So now x into, what is the integration of e to the power x? E to the power x itself. Minus. What is the derivative of x? 1 into integration of e to the power x is e to the power x itself. Correct? Dx. So you get x into e to the power x minus integration of e to the power x dx, which is x into e to the power x minus e to the power x plus, this is your verb. Yes, I hope this is clear. All right. Next one is definite integration, where you're supposed to find the value. All right. Now here you have 3x square minus 2 whole to the power 2. So integration of 3x square minus 2 is in the form of a minus b the whole square, which is a square plus b square minus 2ab. Okay, to dx. We'll integrate it separately. 9 integration of x square plus 4 into integration of dx minus 12 integration of x dx. 9 as it is. Integration of x square is x cube by 3. Two values need to be substituted. This is how you write it. Plus 4 into integration of dx, that is 1 dx is x, minus integration of x is x square by 2. Okay, now you substitute the value of x as 4 first, minus x value as 2. Okay, take this 3 outside here. You will get 9 by 3 into 4 to the power 3 minus 2 to the power 3 plus 4 into 4 minus 2 minus 12 by 2 into 4 to the power 2 minus 2 to the power 2. Okay, yes. So 4 to the power 3 is 64 minus 8, 56. 56 into 9 by 3, 9 by 3 is 3, that is 168 plus 4 minus 2 is 2, 2 into 4 is 12 minus 12 by 2 is 6, 4 square is 16, 16 minus 4 is 12, 12 by 2 is 6, so minus 72. So you get 168 plus 12 minus 72, that is equal to 1 what? Sorry. Oh, here it is 8, no? Yeah. Yes. 4 minus 2, 2 into 4 is 8. Okay. So you get 168 plus 8 minus 72, that is equal to 1 not. Okay. All right. With this, we are done. Okay. Yes, all right. Thank you very much. I hope you learned something and I hope you take back something from this sessions. These 3 sessions, I hope you take back something. And if you have a doubt, you can always drop in the chat box, that can be answered. Thank you. All the very best for your examinations. I hope you whatever efforts that you have put in and you clear the examination. Thanks a lot.